These two fibers are going to be called actin. And so actin is this protein that is able to self-assemble, and it's going to be playing a big role in this story. And so actin inside of your muscle right now has something covering it. So in your relaxed state, when your muscle isn't pulling anything, your actin has this thing called tropomyosin. And this tropomyosin is this thing that's basically covering all the active sites of actin, and it's preventing it from being bound onto by myosin. So this is tropomyosin. And tropomyosin is held onto actin via a protein that is called troponin. And so these are the key players that are going on in your muscle cells right now. And so what happens when your muscle cell contracts is it receives a neurotransmitter called acetylcholine. And I'll just write this out. So acetylcholine, commonly you'll see it abbreviated as ACH, is this thing that basically will enter your the outside of the muscle cell, and it'll tell that muscle cell you need to start releasing calcium ions. And so inside the muscle cell, a bunch of calcium ions are going to get released, and calcium has a +2 charge. And basically what calcium is going to do is it's going to jump onto troponin, and so it's going to complex with it like that. And then once you have this complex between calcium and troponin, the troponin will push off the tropomyosin from the actin. And so what this will now look like is we're going to have the following. So if I have my two strands of actin again, the tropomyosin is going to basically remove these guys. I'll try to draw this out, but basically the whole point here is that the active sites of actin are now exposed. And what this is to say is that the troponin and the calcium complex has just pushed this thing off. And so this is important because now that you have exposed sites of actin, you're going to be able to have myosin heads grab onto that. And so as soon as this actin active site is exposed, another key player is going to jump into this picture, and I'll try to use a good color for this. So we'll go with yellow. No, I've already shown that one. I'm going to do white. And so basically what happens is we're going to have this thing jump onto an exposed site, and this guy is called a myosin head. And so the thing with the myosin head is that it has a lot of affinity for the actin. And so it's going to form this thing that we call a cross bridge. And so this guy right here is called that actin-myosin cross bridge. And the reason it matters is because this cross bridge will be the fulcrum or the lever point at which the myosin head, which is going to contain ADP, I'm sorry you can't see that, but ADP and PI, basically these guys, once this cross bridge forms, are going to leave, they're going to jump off, and in the process of jumping off, they're going to make the spring that is in this myosin head pull the actin filament towards the M line. And the M line is this thing in your muscle within that sarcomere where you have the myosin that's attached to it. So I'll just draw this out. You've got the myosin head that is attached to this M line, and as soon as ADP and PI leave, that is going to cause that myosin head to pull this actin filament towards that M line. And that's your muscle contracting right there. And so once this spring has pulled this guy to the left in our case, what it's going to do is it needs to recharge or reload itself with this spring. So basically you had your spring that was now like this, and it doesn't have any more potential energy stored in it. So you're going to need in your myosin head an ATP to come by. And during this process, I just want to note that that this guy is still attached onto that actin filament. And so when ATP comes, ATP breaks the cross bridge. And so it's going to jump in here and it's going to sever that link between the myosin head and the actin active site. And so that happens. And so moving forward in time here, we will see the following. So we've got our myosin head, and it's got that spring, and it's got ATP inside of it, and it's no longer attached to this actin filament. And so the next step that happens is this ATP is going to hydrolyze into ADP and PI, but it's going to stay attached in this myosin head. And so ATP is going to become ADP plus PI, that inorganic phosphate. And so once this happens, it takes that spring and it reloads that spring. And so this is unloaded spring. This is the loaded spring. And now, because that ATP was just hydrolyzed, it now exists as ADP and PI. And we no longer have that cross bridge because ATP sitting on that myosin head pushed off that cross bridge from earlier. And so with this, now that ADP and PI have just dissociated and they're still on that myosin head, this myosin head is going to be able to repeat this process again. And so it will then grab another spot and form another cross bridge on this actin active site. And it's going to repeat this process going back up here, where because our actin is still exposed, because that troponin is still bound to that calcium ion, this active site is going to get grabbed onto by yet another myosin head. That myosin head is going to then kick off the ADP and the PI. ADP and the PI leaving are going to cause that spring to pull and push the, it's going to be pulling, it's only pulling here, it's pulling the actin filament towards that M line. And then it's going to leave ADP, ATP will then sit on it, break that cross bridge, and then ATP will hydrolyze to repeat this process. And so this thing's going to keep on continuing. And so this is how your muscles are contracting right now. And so acetylcholine was the key initiator of this event. So acetylcholine is the neurotransmitter that a motor neuron would give to a skeletal muscle cell or any muscle cell to tell it, you need to contract right now. And so when that muscle cell sees acetylcholine on the outside, it knows that on its inside, it needs to start releasing a bunch of calcium so that that calcium can then go bind to the troponin, which can then bind to the tropomyosin to expose those actin active sites. And then once those actin active sites are available, the myosin head with that ADP and the PI will grab onto it. That ADP and the PI are going to leave. That's going to push and I'm sorry, using push, but it's going to pull this actin microfilament towards that M line, and you're going to get more and more contractions in this muscle. And so that is how your muscles are contracting. I hope this is helpful. Thank you all for watching. Let me know if you have any questions, and I'll talk to you guys next time.